Good day and welcome to our physics lesson today. Today we're going to do some calculations with speed, distance and time. Now I know physics can be daunting, but if we work together and we actually understand what we are reading, it doesn't seem all that daunting. Now, a few things that we need to know before we tackle these calculations is we need to know the formula for distance, speed, and time. So this formula is normally written as a triangle. Why a triangle? Because it's easier to remember. Okay, so what you would always write down is a triangle, easy as that. Then you have D on top, S here, and T there, which means speed times time. So speed times time equals to distance. Okay, and time, distance divided by time equals to speed. And speed, wait, hold on. Distance divided by speed equals to time. So out of that triangle, out of this small formula there, you have three equations that you automatically will remember if you remember this triangle. And yes, just as with math, we need to write down our formulas every single time we do a calculation. Why do we have to do that? Because the more that you write them down, the easier it will be to remember them later. You don't have to worry about memorizing and saying it out loud for 3,000 times while you're studying your exams. So just do it now while you're practicing your equations. Okay, so let's look at the next formula. The next formula is for average. Now you'll see that it's basically the same as the distance, speed, and time triangle. It's just a triangle again, right? But now you have the average distance, the average speed, and the average time. Okay, and we all know how averages work. You add all and divide with the number of numbers added. Okay. Giving you an example of average is you have four numbers. You have 2, 5, 8, and 3. Okay, you need to add all of them. So 2 plus 5 gives us 7. So 2 plus 5 plus 8 plus 3. 2 plus 5 gives us 7. 7 plus 8 gives us 15. And 15 plus 3 gives us 18, which means this is equals to 18. Now we're not done yet. We need to find the average. The average. Okay, so what do? We add all and then we divide with the number of numbers added. So how many numbers did we add? We added 4. So we divided by 4. And 18 divided by 4 will give us 4.5. So the average we have here is 4.5. Okay, so that is how we work out an average. Now with this one, we have the average of distance, divided by the average of time equals to the average of speed. Or the average of speed multiplied by the average of time equals to the average of distance. Or the average of distance divided by the average of speed equals to the average of time. So it doesn't matter how you work out this triangle, doesn't matter how you throw the dice, it still lands on the same three equations that you will be able to do using this triangle by itself. Okay, so now we've recapped all of that. Now we know our formulas. Let's look at our equation. Okay, equation number 1. It says here, they give us a table. There's 3 vehicles. They give us a distance these vehicles traveled, and they give us the time that these vehicles traveled in. Now our first question says, which car is moving the fastest? Okay, so now we see that, yes, all the time are the same, but the distance traveled is different. Let's work out the speed for each of these vehicles. Okay, so we write out our formula, which is, oh, wait, I need a bigger triangle. Distance, speed, and time. So our first equation is speed equals to distance over time, which is equal to 80 over 50, which is equal to 1.6. 1.6. Okay, this is kilometers per minute. Now the nice thing about this, if you look at the unit of measure, you can see that we divided the kilometers with the time. We divided the distance with the time. So if you see a unit like this, then you automatically know that this is your speed, because speed equals to distance divided by time. Okay, so this is car A. Car B, speed equals to distance over time equals to 72 divided by 50 equals to 1.44 kilometers per minute. This is car B, and we all see that car A is automatically faster than car B. Let's look at car C. So speed equals to distance over time, which is equal to 85 over 50, which then gives us 1.7 kilometers per minute. And this is car C. Okay, now they're asking us which car is moving the fastest. And then automatically you'll say that car C is the fastest, because the number is bigger than the rest. Now the next one is, which car is moving the slowest? And that would be car B. So here would be car C and car B. This one would be the slowest. Okay, it's as easy as that. Work out all three equations. It didn't take us more than 10 minutes to work this out, or to even calculate this out. So you can just work out all the equations, and remember to write out your formula, and remember to write out your units, because if your units are not there, then your answers would be incorrect. Doesn't matter if the number is correct. Okay, so write out the unit of measure. Let's go to question number 2. Question number 2 states that what was Usain Bolt's average speed when he achieved his 100-meter world record of 9.58 seconds in 2009? So first of all, before we start solving this, because we do not have a table, we do not have the information locked down, we now need to write out our information that we have. Okay, so he ran 100 meters. So distance equals to 100 meters. Okay, do we know its speed? No, we don't know the speed. Do we know the time? Yes, we do know the time, which is 9.58 seconds. And there we already have our unit of measure, which is meters per second. Okay, now we can actually calculate our equation. We say we need the speed, so we have speed equals to distance over time, which is equal to 100 meters divided by 9.58 seconds, which will then give us 10.44. 10.44 meters per second. So for every second he ran 10 meters. That is really fast. For every second he ran 10 meters. Yes, that dude is fast. All right, so let's look at now question number 3. Question number 2b. It asks, how do you know that his top speed must have been higher than this? Now, this is when you have to think practically about it. When you run, let's make it a time distance graph. So this is time and this is distance. We might not be able to finish all the questions in this one video, so I'll make another video for you guys, and it will be in the comment section or in the description section. Okay, so with distance, we always start at 0, and he ran from 0 to 100. Let's make this 100. No, this is 10. Yes, 10 times, and this is 100. Okay, so he ran 100 meters in less than 10 seconds. Can you see it starts from 0 and then it got more? Okay, but now they're asking, how do you know that his top speed must have been higher than this? Now, if he was in a constant speed, this graph would look like this. However, he did not run in a constant speed, because we all know in a race, right, we go very fast in the beginning, and then we run in a constant speed in the middle, and then when we get to the end of the race, we increase again. Okay, so now they're asking us, how do we know that his top speed must have been higher than this? Now, the top speed would be here, or it would be there. But we all know that it would be higher than 10.44, because that is the average speed. If it was just an average speed, constant speed all the way, then he would be traveling like this. And we can all see that this line is more angled, and this line is more angled than this red line, which means it would have been, his top speed would have been faster than the average speed. Okay, but how do we explain this? We can write and explain with this graph, or we can just say that normally an athlete will start the race faster and end the race faster than in the middle of the race. You can just write a sentence like that, and then they will understand what you mean to answer this. Okay, so there's no calculation needed. You can show with a distance time graph, you can say this is the average, but these two spots will be faster than average, and you'll get a mark for that. Okay, so they just want to check if you understand that his fastest speed would not be this average speed that we're talking about. Okay, so I'll see you in the next video to solve number 3, 4, and 5. And I hope you understand this equation so far. Remember the formulas, very important. Do not be afraid to calculate things. Do not be afraid to work out the calculations, even if you have to do it 3 or 4 times. And don't be afraid to trust your gut. The more you practice these equations, the more your brain will tell you, that doesn't look very nice. That doesn't look right to me. Let's try that again. Okay, so trust your gut in exams. Trust your gut doing homework. Okay, see you again in the next video.